Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is B10. So in this video, I will present about my final year project PSM2, which is the effect of the intake air temperature towards the engine performance based on B10 fuel. Okay, so basically in this study, the current developed by diesel which is B10 fuel was used to test the engine performance on the diesel engine while analyze the effect of the intake air temperature at 35 degrees Celsius to 60 degrees Celsius with 5 degrees Celsius increment towards the engine performance based on B10 fuel at the constant engine speed and load, which is at 2200 rpm and 40% of load. The testing was conducted by using Yanmar L70 N6 model of the engine model with dynamometer to analyze the engine performance, while the external heater were being modified was used to control the intake air temperature, which connected to the intake air board on the engine model. The intake air temperature seen affected on the certain engine performance, such as brake thermal efficiency and brake specific fuel consumption. The brake thermal efficiency was influenced by lower heating value in the properties B10 fuel, where it's 44780 kilojoule per kg, and the brake specific fuel consumption was decreased with the increasing the intake air temperature due to the turbulence effect that improved the fuel mixing and complete combustion. Next, for the introduction, based on the current situation that we are currently facing with the decreasing of the petroleum sources, with increasing the price of the petroleum fuel. However, the current developed fuel, which is biodiesel, is quite popular among the user and the researcher due to the green environment, besides its having potential to improve the engine performance. The current biodiesel released in the Malaysia, which is B10 fuel, where the palm oil was produced and been blended with the pure diesel with 10% of the palm oil and 90% of the pure diesel ratio. And besides, the recent study show that there are significant difference in intake and exhaust gases depending on the intake air temperature. It's widely known that the combustion and emission performance is highly depend on the availability of the oxygen and the properties of the fuel. The additional oxygen create a very lean device, causing the unstable combustion and fire. In fact, lean aggregate tend to set the longer ignition delay and lower the cost of the combustion. The longer the longer time time to burn. In this situation, the time for the heat transfer from the combustion to the fuel rejection of the pipeline increase, which is leading to an explosion, but the engine operate under the oxygen starvation, resulting in the shorter ignition delay and higher combustion cost, ultimately creating rich devices that produce more unburned fuel. So basically, the situation was lead to start the study with the objective is to study the effect of the intake air temperature towards the engine performance based on B10 fuel, to develop the alternative way to increase the engine performance and to analyze the engine performance based on B10 fuel with the different intake temperature. Next is literature review. The table show that the main literature review used to conduct this experiment, this study, which is the first one is the study in 2022, which is the challenge of biodiesel implementation program in Malaysia. Despite of the successful B5 and B7 program, Malaysia is facing the challenge for the implementation of the biodiesel due to the fluctuation include palm oil price, low domestic usage of palm oil, and the vehicle warranty. The improvement of the palm oil and promotion of B10 through the target agency in the central region of Malaysia will help to implementation the biodiesel program successfully. Next is on 2017, the influence of intake air temperature on internal combustion engine pressure. So the findings from this study, at the higher engine speed, a large portion of the gases feel to be involved in the oxidation process that lead to the higher reaction activity, resulting in lower brake specific fuel consumption. And the third one is on the study on 2020, which is the biodiesel fuel combustion performance and emission characteristic under the various intake air temperature and the injection timing condition. For the finding, it showed that as the intake air temperature increased, the peak of heat release rate was reduced and the combustion period was longer. Increasing the intake air temperature also improved the evaporation rate of the fuel but reduced the ignition delay, resulting in the less forming mixture for the premix combustion. Next is the methodology. So this figure show my flow chart, the process of my study, which is I start with the literature review. Next is preparing the biodiesel and external heater. Next is experiment setup. Which is the engine use, and then I start the experiment. After the start experiment, I collected the data and test the data to see either is valid or not valid, and then I start the analysis and then start writing the report. And until today, I've been presenting my final year project before been final submission. Next, the result and discussion. So this figure show that the torque and power at the constant speed and load with the different intake temperature. As you can see, the highest the torque and power start decrease with the increasing the intake air temperature at 35 degree to 40 degree. However, it start to increase until 9.5 Newton meter for the torque and 2.29 for the power, and then it's continue drop, and it's after the drop to 9.773, then it's continue to rise back. Next is the result from the engine testing, which is the fuel flow rate show that having decrease start from the increasing the intake air temperature from 35 to 60 degrees Celsius, where is only have a slightly increase at 40 degrees Celsius to 45 degrees Celsius. However, it's having to decrease, but it's only have a slightly movement only. Next is exhaust temperature. Is increasing, starting increase the intake air temperature at 35 degrees Celsius to 40 degrees Celsius. However, is drop at 55 degrees Celsius before it start rise again to 60 degrees Celsius. Next is air fuel ratio, which is having a slightly decrease at 35 to 55 degrees Celsius, and proportionally increase at 55 degrees Celsius before it slightly decrease until 60 degrees Celsius. The ambient temperature show that the increasing along increasing the intake air temperature. Next is the in-cycle temperature during increasing the intake air temperature. So at the 35 degrees Celsius to 40 degrees Celsius, the in-cycle temperature was slightly decreased and has been increased from 40 degrees Celsius to 45 degrees Celsius, and then it's continue drop to 50 degrees Celsius before it start to rise to 60 degrees Celsius. And then airflow at the different intake air temperature, which is airflow has been constant at all the intake air temperature tested. Next is the effect of the intake air temperature, which is the figure show that the result of the BTE, BSFC, VE and corrected break power by increasing the intake air temperature. The brake thermal efficiency show that the brake thermal efficiency was increased alongside with increasing the intake air temperature. Next is the brake fuel consumption. It showed that the brake fuel consumption was decreasing with the increasing the intake air temperature, while the volumetric efficiency it showed that it start to increase when increasing the intake air temperature from 35 degrees Celsius to 40 degrees Celsius. However, it's dropped until 14.06 only slightly to 50 degrees Celsius, and it's continue rising until 14.12%, and it's continue to drop at the 60 degrees Celsius at 15.07%. The corrected brake power was calculated, show that the corrected brake power show increasing alongside with the increasing the intake air temperature, which is start from 2.25 at 35 degrees Celsius, and lastly at the 60 degrees Celsius it show that it's almost reach 4.0 kilowatt. Next is brake BMEP at the various intake air temperature, which it show that from the 35 degrees Celsius is dropped to 40 degrees Celsius from 33.885 to 3.81, and then it's continue to rising at 45 degrees Celsius, and then it's dropped back to the 50 degrees Celsius, and it's continue to increase until it's reach 60 degrees Celsius. So as the conclusion, the intake air temperature actually give an impact on the engine performance, such as brake thermal efficiency and the brake specific fuel consumption, which is from the experiment it showed that when the intake air temperature was increasing, the fuel flow rate and the humidity percentage was decreasing significantly, while the airflow was constant with increasing the of intake air temperature. Next, the intake air temperature be able to improving the certain engine performance such as the BTE and the BSFC, while the high thermal efficiency also means lower specific fuel consumption, meaning less fuel is needed to fly a given distance at a given power. Therefore, a practical importance of the high thermal efficiency is threefold, which is one of the desirable characteristic for the engine operation. Lastly is the B10 fuel biodiesel also become main reason of the improving of the engine improvement in this testing. The properties of B10 also give a big impact on the result of this testing. So I guess that's all from me. Thank you.